want to make a real quick video here showing you my solution to the investigative task. First, I would like to comment. Thank you to those students who did their work on another sheet of paper and who did not write microscopically on the handout that I provided. Think about that, you guys, when I have to grade these online, please. Anyway, so when you go through and you solve for n, here's what you are doing. And you end up with 394 point something, and regardless of what that is, when you are solving for the minimum sample size, you always have to round up. Now, all of you used the 0.63 that was provided. I think I told you that. If you had used 0.5, if they hadn't given you something that they already believed to be true, then this is the conservative estimate, and if you had used this instead, you would have come up with a sample size of 423. On number 2, determine a 90% confidence interval for the percentage of seniors planning to go to college this year. Explain carefully what your interval means. So 90% confidence, we have to start by checking our conditions. So we were told that the students were selected in a systematic random sample. Because it's random, each student should be independent of each other. The sample size, we're not using this up here, we're using what they gave us in problem 2. 500 is less than 10% of all seniors. And probably we should have talked about upstate New York because this was, so I should have said 10% of seniors in upstate New York, because that's actually where this data is coming from. So our population really is about upstate New York. So, that's really what the conclusions we can talk about. Now, I mentioned that because the conditions are met, we can use a normal model. If you didn't say that, that's okay. However, you need to say that we're going to do a 1 proportion z interval. Now, this was my p-hat value. So the p-hat value, and that came from planning to go to college, so that came from 289 out of 500. This is the number that's going in right here. That's our p-hat value. So we have, oh, I'm sorry, p-hat value goes right here. So it is our, it goes in both places. So it's our statistic plus or minus our critical value for a 90% confidence interval. That's 1.645. You can get that on your yellow sheet. And then this is the standard error. So you come up with this, and you can name the interval either by, you either name the interval or you can use the formula. You don't have to do both. A lot of you did. That's fine. Here is my interval that you could have gotten from the calculator. What does that mean? So interpreting your confidence interval. I am 90% confident that the true proportion of seniors planning to go to college, and then I added in front upstate New York, is between 0.542 and 0.614. That's what your confidence interval means. Now, if you are asked, we weren't, but if you're asked, what does 90% confident mean? What does that mean to be 90% confident? That means in repeated sampling of size 500, 90% of the confidence intervals I create will capture the true proportion of seniors planning to go to college from upstate New York. I know that's a lot. But if you are just asked to interpret your confidence interval, this is how you do it. I am blank, whatever the confidence level they told you, percent confident that the true proportion of blank, add your context, is between blank, add your confidence interval. Okay, number 3. Number 3 says, on number 3, it says test an appropriate hypotheses and state your conclusion. Now, some of you were still doing a confidence interval, and it says to test a hypothesis. So the hypotheses we are testing is, was there a change between what they believed to be true? During the 90s, about 4.5% of high school seniors enlisted in the military. Do these data suggest the percentage who enlist is different this year? So they're telling you what to use for your null hypotheses. P equals 0.045. It's what it was in the 90s. 4.5% of high school seniors enlist in the military this year. That means it hasn't changed. It's the same as what it was in the 90s. My alternative is not equal to. The percentage has changed. I talked about this on my instructional video, how it didn't give us a direction. Now, the only additional condition I have to check, I've already checked the conditions about my random sample, my independence, and the 500 being less than 10% of the population. But what has changed is my n times p has changed, because now I'm believing this to be true. That's the value that I use here when I'm checking my that particular condition. Is the sample size large enough? So this is then, 1 minus 0.045. That's the only condition that is different for a hypotheses test over a confidence interval. So we can use a normal model, but again, if you didn't say that, as long as you said a 1 proportion z-test, you don't actually have to use the formula if you say it's a 1 proportion z-test. It is not an interval. It is a 1 proportion z-test. Your z-score value you should write down even if you use your calculator. Because it's a two-sided test, I have to double the p-value if I was doing this by hand. But if you use your calculator, you don't double that. You just are given the p-value. So here's my p-value, and now I have to interpret that. That's large. With a p-value of 0.4502, I didn't say large, with a large p-value of 0.4502, there is not enough evidence to suggest the proportion enlisting this year is different from 4.5%. If the true okay, and that would be okay. That's actually interpreting that's my conclusion. I don't have enough evidence. Notice that I don't say that it hasn't changed, because I can't accept the null hypotheses. I can only say that I don't have enough evidence to reject it. So that's all I can say. There's not enough evidence to claim the alternative is true. That's all I can say. If the true proportion is still the same, so if the null hypothesis is true, if the true proportion was still 0.045, then the probability of getting results like our sample is 0.4502. That is not at all unusual. So this is kind of interpreting what a p-value means. If the null hypothesis is true, I'm interpreting a p-value. So you have to be really careful not to sound like you are accepting the null hypotheses. So nowhere in your conclusion should it say, the proportion hasn't changed. You can't say that. You can just say we don't have enough evidence to state that it has changed. Then on problem 4, now they're increasing the amount. They're saying half of the undecideds are now going to, let's assume that they are going to join the military. So that's 11 more people. So now our p-hat value has changed to 37 out of 500, which is 0.074. So again, I did not do this. If you did this, you wouldn't, don't worry about this 2 times the probability. That's only if you were using the yellow table in the chart. With your calculator, you get a p-value of 0.0018. So now all of a sudden, this is a low p-value. So we have a very low p-value, or a low probability. So again, remember, if the null hypothesis is true, so if the percentage or the proportion was still 4.5% of the people who enlisted in the military, then the probability I would get results as extreme or more than these is 0.0018, and that's really small. So now I'm going to say I do have enough evidence to state that the null hypothesis is I'm going to reject the null hypotheses and say that the alternative is true, and I can say that the military enlistment has changed. Now, notice I can't say it's greater, it's gone up, because all I did was a two-sided test. I can just now say I have enough evidence to say that it has changed. So that's what you would do on number 4. Then on number 5, you are just asking, what does it mean to have a type 1 and type 2 error? So a type 1 error means the null hypothesis is true, but we say it's not. So that means that I'm claiming, I'm accepting the alternative. So I'm claiming there was a change in the military enlistment when it had really remained the same. That's a type 1 error. Now, a type 2 error, you want to be a little bit careful, because really what it means is you are, we don't have enough evidence to reject the null hypotheses, but it really has changed. So I'm failing to detect that the military enlistment had changed. And notice by saying it this way, I'm not implying that my null hypotheses, I'm not saying that, I'm not saying, I'm just being careful not to accept the null hypotheses in my statement of that. So failing to detect that the military enlistment has changed. So that's and most of you did okay on the type 1 and type 2 errors. That hopefully helps clear up a little bit. I was really concerned about the people who on number 3 and 4 did a confidence interval. You really need to know the difference between a confidence interval as a type of inference and a significance test as a type of inference. That's really important that you understand that difference. So comment about, since I got you on a video, comment about the AP exam now, that it's going to be, there, in case you didn't read what I sent, it is only going to be free response. There are no multiple choice. It is a 45-minute test. I have no idea what that's going to look like. So I'm guessing 3 free response questions would be all that I can think of. I know we're going to get some more information about the format of the test coming up. I shared the link with you that has some practice or some review type things that you guys can start looking at. I'll be honest right now. I know in the past I've told you I can predict what the test looks like, and in most circumstances I could have, but I've lost the edge now. So I'm hoping that they give us some more information. If there are 3 free response problems, yeah, I'm not quite sure what it's going to look like yet, but we'll get through it. We'll deal with it. We'll make it. So I'm going to keep teaching the new material. You guys got to keep on it and keep watching these videos and keep really working hard. So thanks. Talk to you later.